everyone joining us today. My name is Victor Asachi, and it's my pleasure to lead you through the topic of IoT challenges and modern solutions. Comprehensive look at IoT testing and Rust for IoT development. We're here to dive into the world of IoT, exploring the nuances of testing strategies and the revolutionary role of Rust in development. My bad. I'm actually checking that our our conference is live. It's great. I can see that our YouTube broadcasting has already started, and that's great. So, just a reminder here that we're going to dive into the world of IoT, exploring the nuances of testing strategies and the revolutionary role of Rust in the IoT development. And just a quick reminder that at Yalantis, we're committed to helping businesses bridge the gaps between tech leadership and tech talent gaps using modern technology and software development practices. Our goal is to empower IoT businesses to scale, innovate, and monetize products and solutions effectively. Today, during this live stream session, we'll have two amazing speakers, as well as two Q&A sessions, so you'll get the chance to ask your questions related to the topic, as well as IoT product engineering and using Rust and testing IoT products. If you have any of those questions, please have a look at the chat box on your YouTube broadcast and put your questions in the chat box so that we could later read them out and answer. And I suggest that we start. I'm really thrilled to announce and introduce the first guide for today's adventure. His name is Artur Shevchenko. Artur is the current head of engineering at Yalantis, with a rich background as a former head of QA, SDET, and a PhD in math. Not only he's a teacher at university, he's also an IT blogger and also an avid motor traveler. Arthur will share his insights on what to pay attention to when building a testing strategy and how to tackle IoT solutions during the testing problems. So, Arthur, without a further ado, I invite you to join the session.
Yeah, hi all. Thank you for such a kind introduction. And yeah, let me share the screen and we will start. Just a moment. Is my screen available? Yeah. Hi all. Really excited to share my case studies, my experience today with you. And on this slide, you can find the links where to find me, my YouTube channel, my Telegram blog. But all information there will be in Ukrainian, so it's a great time to learn the most beautiful language. And today I would like to talk a bit about IoT, Internet of Things, and the most interesting is how to test it, what failures you may face with. And our agenda is the first will be a little like introduction about IoT in general. Then we learn the one of the approaches how to test it, and of course I will share our failures that we faced with. So what we will not see and will not learn is how to connect the toaster to the internet, or like silver bullet for all IoT projects in the world. But there will be a lot of memes, a lot of jokes, and a lot of useful information for you. So once a time, new project is coming to our company, and they had a call with an architect and business analyst. And they said that a really well-known company wants us to develop an application for them. And this application plans to have a web admin, a mobile application. All it will be in microservice architecture, and our team will immediately have around 80 people. And yeah, there will also be various devices that send the data from different kinds of vehicles like cars, buses, scooters, and others. And my condition after this meeting was something like this. But then I calm down and remember my most favorite phrase that we should eat a whale in chunks. Yeah. And my whale, there was this device, this sensor, which will be installed into the vehicle and send some data. But let's talk a bit about what it is. What is the Internet of Things is? Um, the Internet of Things is the transfer of the data between physical objects, the things, that have some abilities to interact with each other or with external environment. And people first talked about Internet of Things in 1991 at the Procter and Gamble company, and they talked about how radio frequency tags can affect the optimization of logistics process. But also, um, even more earlier was the first attempts of the Internet of Things. In 1990, one of the investors of TCP/IP protocol connected his toaster to the network. And now the Internet of Things is really everywhere. So, for example, the scales that weight you and store information about your weight over a period of time and build, for example, some weight graphs. Or it may be a device in your car that sends some data about the location of your car, and somewhere in your application you may have like something called a safe zone, for example your garage or parking lot, and if the car leaves this safe zone you receive a message on your phone. And the Internet of Things has the following types like M2M, IoT, and IoE. So M2M is a subset of the Internet of Things. It is a closed communication channel of physical devices. And this technology is work between only between devices without any human intervention, and in general it is like one-to-one connection. The IoT, like Internet of Things, it connects a physical object with other objects through multiple points, and this is like one-to-many connection. Um, it can use like really a lot of technologies, like protocols like cellular data, wired, short range, wireless, satellite, and really many others technologies to communicate. Um, IoT is a subsystem of IoE. IoE is the last stage of Internet of Things, and IoT it is Internet of everything. And it is interaction of a person and several IoT solutions. For example, it may be a car with some device that send data of this of the location of this car, and for example cameras at traffic lights that analyze traffic and simultaneously correct the route of current vehicle. um, Also, let's define what the infrastructure of Internet of Things consists of. So, for simplicity, this principle is may be represented as A, B, C, D, E. So, A is analytics, B is big data, C is connection, D is devices, and E is experience. Um, Analytics, it combines the devices themselves and the data from them. Um, so once the data is received, it is necessary to conduct an analysis of this data and maybe build some reports, build some dashboards, I don't know, maybe make some forecast. Big data is information from the device, and it's really, really important things. Because imagine that you have, for example, device in a vehicle that send the data, for example, every 3 seconds. So in one day, there will be almost 30,000 of records. And in 1 month, it will be around 900,000. And if you have 1,000 vehicles in your system, it will be about 900 millions of records in just 1 month. So it's really a big amount of data. And you may have in your system some reports, some statistics that can be built up to 1 year. So imagine how much data you have in your system and you should analyze. So the next one is C. C is connection. Connection are the channels through which devices receive and send some information. So it's like a protocols of different levels. These devices are actual devices connected to our system, and their their various settings for work. Because, for example, they may have settings for appropriate frequency of sending the messages. Yeah, and the last one is E. E is experience. It is the solutions of the problems that mm, that may help you and already implement. Because uh, create a unique project from scratch may be quite expensive, and there may be already created the device, and there may be a lot of successful cases, and you just need to use them or adjust them to your needs. Uh, where the Internet of Things used? Literally almost everywhere. It used in the factories, in city infrastructure, in retail, in healthcare, in logistics, really everywhere. And in our case, we had a project in automotive industry, and let's take a look how the cars evolve to understand what is IoT in the cars. So first, there were cars without any electronics. Then the cars began to evolve, and at some point of time, the cars um, had their own onboard computer. Yeah, it showed to us like some engine errors, some fuel consumption, and etc. You all drive the cars, and you all see this information. And the next step was the appearance of devices that could connect to vehicle, read the data from the vehicle, and send it somewhere. Okay. Um, how it may be useful to us. So, what is the value of this? Because in order to properly test a product, you need to understand why it is produced, understand the goal of this product, and not only know the technical details of implementation of this product. And it is necessary for us first to track the location of the vehicle, because sometimes drivers do not go along the intended route, and they may increase the mileage or go about their business in a company car, or also they may grab some unexpected parcels on the way, and it really a lot of examples of this. The second one is, of course, we may need to control the fuel consumption. Yeah, because depending of a type of driving, fuel consumption may really vary. The third one is again based on a second point. It may also be a control of smoothness of the braking or acceleration or the car incidents. And we can use this information for example, to build some ratings of like good and bad drivers, and probably some gamification in driver ratings. The fourth, this is also maybe the monitoring of the checkpoints. So the drivers arrive at the drop-off points on time, and we may monitor this arrival time. All this helps us to monitor and control your business in more detailed way, and it also may help you to identify where your business has some bottlenecks. And one of the biggest risks for testing is the behavior of this device that would be installed in a car. Okay, we identified the risk, and what should we do next? Yeah, next that we should do is we need to plan exactly how much time we uh, we have to learn how this device works. So for this, you can break your project in smaller like parts, smaller chunks, and for example, use Gantt chart. So I've got that we will have around 4 sprints before the device related feature will start developing. And one morning, I woke up and see a message on my phone that there are 3 parcels coming to me, and these mysterious parcels was with our devices that will mount in the vehicles. And when I opened this parcel, I saw some wires, some black box, the first black box, the second black box, the third, and again wires. Some. So let's figure out what's going on here. And the general principle of many devices of Internet of Things is next. So we have some kind of a box in which there is something called a board that is responsible for some functionality. Or in addition, we may have some kind of a sensor. Of course, it must have a power source, and usually all these sensors have their own battery, but it may be also some options for external power. And device also must somehow to communicate with your server. Yeah. Usually it may use like Wi-Fi or SIM card for this, but there are may be a lot of another different protocols, like MQTT protocol, BLE protocol, LoRaWAN protocol. In our case, our device uses TCP protocol, and so your device may really vary on the type of communication. So then we should buy, obviously, a SIM card, buy some power supply unit, again, suitable for your device. Then we need to configure the device, because maybe even not some, many of IoT devices have external software for configuring the device in a certain way. For example, how often the date will be sent. Yeah, the frequency of sending this data. Then we connect this device, and cheers, the data starts to be sent, and our server starts receiving the first messages. Um, Everything's look great, but there is no much data yet because now the device is sent only location. So we need real vehicles. After finding some volunteers, there was something like installing these devices in real cars, and their first fail was waiting for us there because not all the electricians are good, and not every one of them was able to correctly connect the device to the vehicle. And one of the vehicles sent only a location. The second did not send any types of messages and sent only fuel consumption. Other ones sent only battery level or speed level, and uh, all the vehicles have some troubles. But we continue the development of new features and test them. And the only inconvenience was that sometimes people with vehicles had to be asked to drive along some certain road and in a like certain way, because uh, sometimes we ask them like to turn the engine off, to turn the engine on, idle for a couple of minutes, or suddenly brake your vehicle. And in general, everything seems to be going well, but at some point, uh, new requirements have been received that the devices must be as soon as possible reconfigured, because tomorrow we should have some a new demo with other customers and need to reconfigure the devices. And what to do, because the devices are really deep in the cars, and in order to get them, you should found an electrician, disassemble the car, remove the device, connect device to computer, reconfigure it, and again put it back into the car. And it really took a lot of time, which always is not enough. So what should we do? And next, what I thought is that if device has a SIM card, so theoretically it can receive the messages. And if these messages come to device, it most likely that manufacturer of this device had to provide some format of communication with device through SMS. And after studying the device documentation in more details, I did find that it's really possible to configure our devices using just an SMS. After about 30 messages and like 1 or 2 hours of work, all the devices were successfully reconfigured. And as you later found out, quite large of number of devices can be configured through SMS commands. And yeah, you should take it in mind that it is like one of option to configure your device. And after that, I realized that I need to learn more about how this device works. And I found out that device uses this TCP binary protocol to communicate with the server, and it has some specific message format. In general, it looks like something like this. So first, device sent its IMEI to the server and authorizes, and after that, device starts sending the real data, and server can accept it, can parse it, and store if it needed. Okay, I thought I know the message format, I know what protocol it use. Why don't I make like drum roll simulator of this device? Because in this way we will not depend on any external factors. There will be no need to ask people to, I don't know, turn on their cars and ride where I need, or turn off engines, or idle, or anything else. And by having this simulator, I also can configure the device as I want for my testing goals. And also it will be possible to check quite a lot of edge cases. Again, edge cases of simulating an accident or sudden braking or any other things without exposing other people's to risks. So let's start coding. But I realized that in addition to me, there will be a lot of other members with junior levels, or I don't know, maybe some manual testers on the project who may find it difficult to understand the code and to use it for testing goals. So I started to think how can it be done in more simpler way for them. And I found that Gmeter can help us in solving this problem. Because Gmeter can work with TCP protocol. It really has like simple interface, and all this data conversion implementation can be hidden in a jar file. So first, what we need to do is make some proof of concept of our idea. Yeah. For this, we need to create TCP sampler, write some class name. In our case, it will be binary TCP implementation. We need a server, we need port, and in the text field, we will write the converted device IMA, and again, this is how it looks. So first we send the converted IMA. The second we send the data again in hex format, and after that, after we send this information, we see that our server received it and successfully displayed. So woohoo! Our POC, our proof of concept, is successful and it works fine. But we can improve it in more parameterized way. So what we can parameterize? First of all, it is location. Next, we need, of course, speed of a vehicle. Also, because each event comes at a specific time, we also need this time parameter. Also, vehicle may have like a battery level, fuel consumption. Also, it may be like different kinds of events like sudden braking, sudden acceleration, sudden turning, accidents, speeding, excessive idling, and really a lot of them. And it would be great to put also the domain name and port also in some variables, because we may have a lot of different environments, and to easily manage it, we parameterize the environment configuration also. So we may have develop environment, test environment, stage, production, some custom production, and etc. Yeah, for this, Gmeter has something called user-defined variables. And also, as I mentioned before, we will hide all these internal conversion operations in a separate external file. So we will have like two classes. The first one is about the device data, and the second class will be responsible for events from the car, like accidents, braking, acceleration, and all other stuff. And on this point, you may ask, why are the byte events are different, like 1, 2, 4, and 8 bytes? It is because of device can send the data of a different length. For example, one byte is enough for event like an accident. It is on or off. 2 bytes is, for example, for fuel level. 4 bytes may be used for, I don't know, for odometer value. So on one hand, we have some classes that converts the data, and it was written in Java. On the other hand, we have Gmeter. So how to connect them? Yeah, we should make them like friends, and for this, we should make a jar file from our classes and connect it to Gmeter. And in Gmeter, there is thing uh, where we may insert our class path for our jar file, and actually this is all that we need. Um, Also, we need some kind of preprocessor where our data will be converted and then sent. So now we get our simulator a bit smarter, and now we can test different like situation in more detailed way. For example, if the battery level icon on our front end changes depending on the data that is received, or some cases where we send some events like car incident and check that some kind of notification received on the UI side. But the real device doesn't work like that, because in real world, the device send the data every three seconds, and we have to test our system in close to real life conditions. So we need to test mm, our system in a like scripted way. What does it mean? Um, the car, imagine that the car is driving, yeah, and it changed the time of sending messages. Um, Also, the values of a fuel level changed, odometers changed, the speed is changed, location, and really many other parameters. And how can we simulate this? For such scenario testing, we can create a file with our like a vehicle script for some period of time, and also connect it to Gmeter. So this is how, as an example of file with parameters can be looked. And next that we need is to attach this file to Gmeter. And for this, we can use config file, read config file. And next, for like a completely realistic scenario, we also add a delay as a 3 seconds to simulate like the real behavior of this device. So at this point of time, what we got? First of all, we authenticate the device. Then we send converted device name using this TCP sampler. Then we read data from the CSV file, which is actually the script of our device, of our vehicle, and then send this data using again TCP sampler with delay of 3 seconds. So now our simulator has become really quite smarter, and we can test all the scenarios without any problems. And um, it's like a real car making some trips, but without a real car. So it's like the maximum imitation of a real device. And there it is. So the one approach of testing Internet of Things is to create a controlled simulator of the devices, of the things. Yeah. But after that, another failure was waiting for us. And um, remember, earlier I talked about the infrastructure of the Internet of Things, and there be a letter B, like big data. And this is exactly where we have a huge bottleneck. So when you test the various type of devices, do not forget about such a part as performance test and volume test. Volume test is testing your system on a large amount of data. And again, the advice for me, it is better to generate this amount of data not through the full like a path of interaction of the device, but using direct insertion into the database. And then we had some more failure, is that the sensor sometimes started sending like nonsense, some invalid data. um, there may be like some like jumps of odometer in our case, but this may also be easy fixed, adding some data filtering in your system. So this is all. I was really happy to share all these cases for you, all these approaches, and summing it all up, what we learn is what does Internet of Things consist of. We learned about the one of approaches of testing the Internet of Things, like creation of controlled simulators. Also, we found out what pitfalls you can face with when you build your IoT solutions, like problems with installing device, their configuration, the also it may be the issues with data quality of your devices, the issues with a large amount of data from your devices. So if you have any questions, let's discuss. And finally, don't forget to support Ukraine, love your mom, and write tests.
That was such a pleasant conclusion. Thank you so much for your presentation.
Yeah.
It was a really immersive kind of one. I mean, like we got from the history, from the concept of IoT to IOE, right? It was quite a journey, and thank you so much for sharing the example of how it could go and what to do and what not to do.
Yeah.
I'm actually monitoring both of our streams on YouTube and as well as on LinkedIn, and we already have two of them. The first sounds like this. Let me just show that to you. It's quite a long one, so I'll also read it out. I'm interested in understanding the most effective way to integrate automated testing into our development cycle. What are the best practices for implementing automation in testing IoT devices, and how can we ensure coverage across different devices?
Mhm. Uh-huh. So about integration of the automated testing. First, we should clear define the testing, and we should define like objectives, areas of the automation, the level of the automation, and all these things, and of course describe it. Next one, we need to understand our IoT system at all. So we need to understand the architecture of our system from the technical perspective, because on this point we also may found that we may faced with some problems even while reviewing this architecture. The next one, we should select the like right tools, because for testing IoT devices is may need you some investigation of the tooling that market has, and building some, first of all, building some proof of concept, because your idea may fail, and it will be better if it fails on earlier stages. The next one, we should we should care about the testability of our system. And it's really hard thing because um, it may take a lot of efforts from architecture side, from development side, but testability, especially for IoT project, is the really part that may affect all your system at all. Uh, Also, we need to be focused on test design. Uh, Also, let me think. Yeah, the standard practices is when we start automating, we should definitely implement CI/CD processes, and we need to do our tests as much as possible easy to execute, because um, it should not take a lot of efforts, a lot of time for whole team to run your test and get the results. And of course, we should educate our team again how to run test, how to analyze the results, and how to work with this. So yeah, I would say that this is the the top best practices in providing automation. Yeah,
That sounds like quality by design, right?
yeah.
Well, thank you so much. Got one more question from the audience. Well, the first one is a bit jokey, so I guess we'll skip that one. But the next one is quite serious, and it's about covering any hints for IoT devices firmware and embedded systems QA. Any kind of special advice on that topic?
Ooh, firmware and embedded system, it's really another, I would say, type of conference will be, because this is like another world. And the approach for testing firmware or like some of embedded part may really vary. I would provide you some examples of from my own experience. So once we have device that measure the angle of rotation, and we build the actually like another device that where we put our test device and connect it to some program that simulates rotating the our test device, and we compare the angles that device measured and angle that we measure. The next case that I have, also device, was with humidity sensor that measures humidity, and we built another device that put our test device into the liquid, and we see how the data changes with different kinds of firmwares and different kinds of builds, and compare the results. So it is also about automating some processes, and it really interesting part of this. Yeah, so I would say something like this.
Yeah, that also looks like that sounds like a real adventure. I mean, it's not only about working out with software, but it's working out with hardware and some mechanisms for
Yeah,
testing, right?
yeah,
All
yeah.
right. Well, thank you so much. It was a rather interesting presentation, and I'm sure that there will be more questions to cover. So, guys, don't worry if we don't answer them right away. We'll be able to do so later on. We will collect all of the questions that you have and then reach out to you. Just please let us know what questions you're interested in. And one more thing is that we will be also spreading out the thesis of the presentation that Arthur has just given. So later on, we'll be also sending it to your email. So please don't forget to check those. And Arthur, thank you so much for sharing all that kind of information and also presenting live experiences. Thank you so much.
Yeah, thank you too. Thank you for your question, and hope see you on other our webinars.
Yeah, yeah. See you. But it's not the end, right? We have to move on, and it's a great pleasure for me to introduce our next IoT and IT expert, who is Mykhailo Maidan, the head of the Rust department at Yalantis. Let me just help him get into the stream. All right,
Hello.
Mikhailo is already here. So Mikhailo is a software engineer with over 7 years of experience, who is focused on building distributed and IoT systems, and he will be enlightening us about the perspective of Rust for the IoT industry, guiding us on how to build prototypes, and building prototypes without any hardware at the initial stage, which is rather awesome. And he'll also be showing off some of the real examples of firmware for IoT devices using Rust. So I guess the question of testing and developing for firmwares and embedded solutions is going to be definitely covered in a way. So please, without further ado, Mykhailo, I give you the stage.
Yeah, thank
Yes.
you, Victor, for such great intro. And let me share my screen. Screen. Uh, okay, and slideshow. So I hope that you see my screen. What I actually will cover today, I will cover the Rust for IoT advantages and disadvantages for business to use Rust as a main programming language for IoT solution. And as already Artur covered what the IoT is I just go through that topic very quickly and go to the next step. So a little bit about myself. I'm head of Rust department at Yalantis. Actually, a lecturer of a distributed system at Lviv Polytechnic National University in Ukraine. And in the past, I'm embedded engineer, so I use C and C++. So that's why perhaps I'm bald and have a beard. Um, so if you want to keep in touch with me, you can go to the link to my Telegram and LinkedIn. And let's move forward. And what is my agenda today? I will cover what the IoT is, but from the perspective of things, which is called it in Internet of Things, what the thing is and how we can program it. We will choose the right language for embedded programming. We'll take a look how the Rust actually can help here and what kind of benefits it brings for business to use Rust against C++ and C, for example. And we will take a look into the IoT ecosystem in the Rust community and a little bit practice in the end. And I will show how to program ESP32 and how it can send data to your MQTT broker. So what's the IoT is? Internet of Things. So it means that I would say from my perspective, it's the system where the thousand of small devices connected with server or servers and send data in real time to the servers, and server actually process this data and send some command to that device. So there are a lot of things can be in the middle of the connectivity between smart devices and servers, like edge computing, something like that. But let's focus on the things. And things actually in Internet of Things is the real device, small device. It can be actually the big one, but usually it's small device embedded to some practical things which we use every day and every time. And this device send data about everything around you, like humidity, temperature, heartbeat, location, etc. And all these devices should be like, we also need to write program for this device too. And this is actually what is called embedded programming, and it's very popular things in IT industry. So let's move on. As I said, the things can be everything, like kettle, vacuum cleaner, watch, smartphone, coffee machine, etc. Actually, everything what you use at your house can be a smart device and send data to some server and collect this data and like handle somehow this data. For example, to make your coffee better, for example, if you don't like the current one. And let's talk about the Internet of Things from the embedded programming point of view, and let's choose the right languages. For example, if you have a good idea, you want to create some smart device, you need to write program for that smart device, which is called firmware, and you need to choose the right technology stack for this embedded part of your solution, and they actually not know a lot of like items which you can choose, like a few, just few. But before that, let's take a look to like a small example what the embedded device can be. So it's usually microcontroller with small processor, CPU. It has a low power. Has limited memory. It's energy efficient. Usually, it's use wireless connectivity, but with a bad internet connection. And the thing is that such device, like the business can have 1,000 of such devices, and that's how actually use the very basic IoT device is one of the most popular microcontroller ESP32, and I actually will show a demo on this microcontroller today later. Yeah, let's move on and choose the programming language. As I said, there are no a lot of options actually. The Python, but you can see from this picture that it's actually Python may be good for prototyping, but it's not so good for example, for production environment, and it's not mature. I mean, the Python is as a language is very good, but it's not for the embedded programming. The main winner, and actually the languages which is like used in that in embedded programming for many years is C and C++. But from this image, you can see that it's like very hard-working guy with a serious face, and it's really understand how it's working and what this guy is actually thinks. Or you can use assembly and just become a crazy for for a few weeks, and you still will not get anything from your device, because it's not very good idea to use assembly right now for programming. And actually, it is the place where the Rust come to stage, like young and full of energy. After 30 years of domination from C and C++, Rust actually become very popular system programming language right now. It has the same advantages as C and C++. It has multipolar paradigm. It also has zero cost abstraction, so you don't need to pay for the things which you don't use, and it's adopted by big companies. Like it was founded in Mozilla. And actually, big company understand that Rust has a big future, and they just start to use it, like Microsoft, Discord, Dropbox, AWS, Google, etc. They just understand that better to use Rust for efficient programming instead of C and C++, because it brings more value than C and C++. Okay, so let's talk about Rust, if it's good for IoT or not, and can we use Rust for IoT devices, like write the firmware for most popular microcontrollers or not? Is it ready for that? And yeah, it just as a small joke, I would say yes, it's ready for that, and I will show you why I think so. So first of all, Rust has it's memory safe, has concurrency support, it has like security support. A lot of things actually require quite good security, because everything what a smart device sends to the servers is actually user data, and it should be secure very well, because someone can steal it and use against the users. It still should have a good performance, since it will be running on the small devices with limited resources. It should has a good ecosystem, and Rust actually has a good ecosystem and very friendly ecosystem. there should be a lot of open source solution which like can be as an example, or actually a lot of open source solutions show the maturity of the language and how this language actually how the other people working with this language, and do that people like this language or not. And it should support modern feature from programming theory, because for example, C, it's not support modern feature, and I would say you can write something in C and you can write something in Rust, and you will do it with less amount of code, etc. But Rust also has a lot of disadvantages, like learning curve. Like I would say for the new persons, learn Rust a little bit hard, because it's not like C based languages. It's more functional language. It's not use object oriented paradigm. So need to understand and maybe adapt yourself for this language, because it's not working as other languages. For now, there are also limited IoT-specific libraries like solutions, real-time system, operation system, etc. So it's still growing, and a lot of people working on some solution libraries for sensors, etc. But there are still way to improve the ecosystem. There are no a lot of developers in Rust for now, but community is growing up. And since the big company just use the Rust and they showing the advantages of Rust against the other languages, the community growing. And I think it's the most growing community right now. And tooling for embedded programming is not so good right now. Like it's also improving during the time, but there are still a lot of things which need to do. And based, for example, compared to C and C++, which is living for 30, 20 years, there are a lot of tools, but Rust is not so old, and the tool set is not such big. Yeah, but actually disadvantages is not so pain point compared to advantages, and I will show you compared to against the C and C++. And for example, a lot of people say that C and C++ it's the bad languages because they know they have a manual memory allocation, and developer need to understand how to work with that. And small problem can cause a lot of problem in production. Like small failure can cause a lot of problem in production. And it means that, for example, your IoT device just stopped to send the data because something happened with memory, or you get the memory leak, and that's all. So you need to understand what's the problem and maybe update your firmware. And compared to C and C++, Rust doesn't have such problem because it's use strong static guarantees. So it means that memory safety is built to the type in Rust, and everything what is reading in Rust, if it compile 99%, you can say that it's working fine, because Rust doesn't use the manual memory management. It's I am calling it automated manual management. It's not it doesn't use garbage collector, but it doesn't use the same approaches which used by C++. So it's a winner for sure here. Concurrency support. So C++ support concurrency. C has a limited concurrency support, and Rust has a good concurrency support with a lot of safety and guarantees on the compiler time. Safety guarantees. So actually, since Rust has a good ownership model, and how the how the theoretical Rust is explained, it actually guarantee the very good safety on the compile time and the runtime, and actually C and C++ can give you that, and because it doesn't use, for example, immutable variables or something like that. So modern features, as I said, C actually doesn't have any kind of modern feature. C and C++, they use modern feature. I would say the modern feature like pattern matching or like other support of async operation, etc. C use different libraries, which is like developed by other developers, and sometimes this library is not so good for using. For example, OpenSSL is great library, but it might be not super user friendly for developers. Yeah, compilation speed, it's always important for such language like C and C++ and Rust, since they have a lot of type checking during the compilation, and actually it's compiled languages. I would say C has the fastest compilation speed. C and C and Rust doesn't have, because for example, Rust during the compile time, Rust need to check a lot of things, and that's why it has a lot of guarantees, because during the compile time, compiler check a lot of things. And C++ actually also doesn't have a good compile speed, because it also check a lot of things. Community support, since C and C++ live like more than 30 years, the community support is very strong. There are libraries for everything what you need, and there are like a few options for each request. So we can choose what library you want to use for your purposes. And Rust actually it's growing, so there are not like a lot of libraries for any, like for example for TLS or for embedded programming, but it's growing. Community actually developed the new libraries, and this library is far more better than, for example, libraries on C and C++. Ecosystem, the big ecosystem on C and C++ and Rust is growing. Development speed, I would say that slow for three of that languages, because it's system programming language, and for example, C will be the slower one here, and C++ maybe and Rust a little bit faster, but it's still slow compared to, for example, to Python or Node.js. But you need to write a good solution for a limited CPU, and you can't just rush that solution. And the tool chain, and this is the my like most important, I would say, how to start the development, and how you can like create the environment, how fast you can create the environment. And I would say that Rust is a winner here, because even that C and C++ live like for 30 years, there's still a really bad tool chain, and then still they doesn't have the standardize the build system, like it use make, CMake, automake, other systems, and Rust actually has it, cargo, and it's actually working very good. It's working with different dependency, and compared to C and C++, it's really godlike. And I even say that compared to other languages, is also far more comfortable to work. Okay, so let's move on. Let's take a look into the IoT ecosystem in Rust, and let's take a look what kind of projects we have if you want to learn build our solution by using Rust. And the first one is the Talk OS. So it's the real-time operation system written in Rust. So the kernel is written in Rust. They have also support to use C like model. It's modular, so it means that you can add everything what you want just to create the new model. It has a good tool chain. It has a good documentation. It supports many boards like microcontrollers, vendor like STM, Raspberry Pi, Nordic Semiconductor, ESP32, etc. And it's really it has a lot of examples how to start to build a small device, a small project, and just add new features to that project. So it's a really good solution, and it's written in Rust, so it means it's very fast. The next one is one of the like famous solution in the world. It's Riot. Is the ecosystem for IoT solutions. It's not written in Rust, it's written in C, but they actually add support for Rust. It's not good for now, but they are improving that support, and it means that they think that it's Rust become even more popular, and it means that in the future, we will see more and more embedded solution written in Rust. So they just starting to add support for that language. They support different microcontrollers, many boards. It's also has real-time capabilities. Also good documentation, good tool chain, a lot of examples. So if you want to start just your project, you could just take a look into that and use it for your purposes. And another one is the Embassy. It's actually a framework for IoT solution written in Rust. Embassy actually support async operation. It has own executor for async operation, and it's really good when you want, for example, to build a bigger embedded device, for example, based on the Raspberry Pi, where the limitation is not so serious, like, for example, compared to other microcontrollers. Actually, Raspberry Pi is not microcontroller, it's the microprocessor. So it supports Rust application. You can write any kind of application and run it in Embassy ecosystem. It supports different protocols, like it has implemented different protocol for IoT, like LoRaWAN, BLE protocol, Bluetooth Classic, MQTT, LW, M2M, etc. It also has a good documentation, good tool chain, and you can add everything what you want just by creating the new mod. Yeah, let's take a look to not such big, but still important libraries and frameworks in IoT ecosystem. So the first one is AWS IoT Core. They provide support for Rust, and it means that AWS also understand that there will be far more solutions written in Rust for embedded systems and IoT systems. It's actually a good sign that we can use Rust for IoT Core. ESP, like Espresso company, which is built ESP32, they actually also provide official support for Rust, and they built a lot of examples, a lot of good libraries, a lot of good abstraction, how to, for example, build a simple MQTT client and connect to some broker and send the data. There are also official embedded hardware abstraction layer for embedded system, and this hardware abstraction layer supported by many companies such STM, Raspberry Pi, Expressive, etc. There are also open source solution on the GitHub, which is called Rust Embedded, and they have a lot of example on different platform how to build embedded firmware for that system. And small, like it's not small, but big framework EVA, which is also used for IoT system, and they allow to like write simple like prototype, etc. for embedded devices. Yeah, that's kind of all about ecosystem. Let's move on to some summary before I show what kind of company adopt Rust for their IoT solutions, and show the small practical presentation. So summary: Rust is the secure and fast language. So is the Compared to C and C++, Rust is also super fast and even faster than C++ in few cases. So C is still faster than Rust, but I think the memory safety guarantees and security guarantees which Rust bring actually win compared to speed. It's like not so big deal with that difference with speed. So it's mature for embedded programming. Even right now, when the ecosystem is still growing, Rust is mature for embedded programming, and we can write any solutions by using Rust. The ecosystem is growing year to year, and it means that in the few years we will see the maybe half of the new embedded devices will be created by using Rust as a main language for the firmware, and have a good tool chain which is like help you to start development faster compared to C and C++, which is the main language in that area. Yeah, let's take a look to companies which is using Rust for IoT solutions. The first one, it's the Samsung SmartThings. They actually use Rust, and they saying that on their official site that they using Rust for the SmartThings solution and for embedded devices and or let's say smart devices. Starlab is the company which is creating security solutions for the embedded devices. They also use Rust. Fire Emergency New Zealand company, they also use Rust for their embedded devices. It's they actually working with the emergency things and use this embedded device in their track. Rotific is the company, they actually logistic company. They using Rust to create better road to some points on the map. Evo and Eva. Evo is the Ukrainian company which is create the logistic solution, and they also use Rust for different embedded things. Eva actually is the IoT platform for automation, like manufacture, etc. They create own framework for that automation by using Rust. So this framework is open sourced on the GitHub, and you can check, and 68% of all codes is written by using Rust. And Next Billion AI, they using Rust for also logistic things. They actually writing device tracker in the truck, and like it sent information about the location of that track. We also built our own platform for IoT solutions, like to help business automate device management and data management, data analysis, etc. So our platform allows just to, if you have a smart device and you want to have a software to manage that device, to analyze data from that device, you can easily use our solution. We can connect any kind of device what you have to our system, and because it's very modular, so we can create any dashboard which what you want, or create any kind of device management system. So if you're interested, just contact with us. We can help you to automate a lot of process at your company. And yeah, before I end, I want to show you some small practice things. I have actually like just I need to understand that. Okay, you see me. So I have a small example, a practical device. So it's ESP32. Like it's typically using in embedded programming for IoT devices. Actually, is the humidity and temperature sensor, and the firmware in that device written by using Rust. Yeah, and it's you like connect to my Wi-Fi and use MQTT client to connect to the MQTT broker and send some data. I can show you how the firmware looks like in my Visual Studio Code. So actually, it's really simple. But first of all, I want to show you what the ESP provide, what kind of ecosystem they provide. So they provide a template for your IoT solution. You just generate that template with the main function, and everything what you want to build, you write to new files. So all scripts or configurations or all other things which need for the comfortable embedded programming generated automatically by this template. And everything what you need, you just write the new code to main function or create the new files, and that's all. And it also provides this simulator, let's say. For example, you don't have your own ESP32 and other sensors, but you have the good idea and you want to create the firmware for that idea, like small POC. You can use service like Walkwe. I will show you how it looks like. So it's like this Walkwe, and you can actually simulate this device. You can see that I actually add ESP32 here, and this is the humidity and temperature sensor, and the same firmware, completely the same firmware as here. So it's the same code base, and I can actually run it. Yeah, it connected to the Wi-Fi. The Wi-Fi is virtual for sure here because like doesn't need to connect to the real Wi-Fi. But the device here is also virtual, but it's behave as the real one. So you can see that it sends some data to the MQTT broker. Actually, topic is ESP MQTT demo Yalantis, and I want to subscribe to that data. Actually, I already subscribed to that data. Yeah, let me just turn off the real device. Yeah, you can see, for example, that give me a sec. Let's clear this one. Connect. Okay, I'm connected. Here. Sorry, the topic is wrong. Subscribe. Yeah, and you can see that the data is actually here, and I can see that device sends some data, and I can see that data here, and actually I can change this data type. Yeah, and you can see that it also changed. So I can simulate the environment, for example, and also I can like add some another for example, I want to add some another sensor, and I can choose this sensor here. They're actually not only sensors, there are a lot of like engines, displays, etc. So it means that you can prototype your device here before you start develop the real hardware with real firmware. You can just write the firmware, understand that it's working as you expect and as you want, and buy the devices and write this firmware to that devices. But of course, like it's not the silver bullet for embedded solutions, because not like there are a lot of many sensors, but not all of them is here. They still adding this sensor to that services, but if you have like some specific requirements, you need to build a real POC solution. And I can show you the same with the real device, which I showed before. Like just turn on, and this is the connected. Let me. This I need to connect to the device. I can install a new application, but it's already installed. I want to see the logs from that device, and for example, yeah, I can see. I want to reset that device. It's reset. You can see that it's starting to connect to the Wi-Fi, connected to the Wi-Fi, and start send some data. And yeah, the temperature is 23.8, for example. Just let's change a little bit. Yeah, the humidity, for example, change it. Temperature, not a lot. Yeah, a little bit. And for example, I want to see that data from my MQTT subscriber, and yes, we have this data here. And actually, I built this solution like for 2 hours. Like I didn't write an embedded solution on Rust, or even embedded solution for a few years, because I was an embedded engineer, but for now I'm a backend engineer and building distributed systems. So it's not a big deal to write such a simple solution, and you can add far more sensor or make it more complex, and it still be easy. And as I said, it will be much safety than, for example, using C++ and C. Okay, that's it from my side. If you have some question, we can actually discuss it, and I hope that you enjoy my speech.
I definitely did. Thank you so much for the real life presentation. It was awesome to see not only the theory but practice and work. We actually have some questions from the chat, if you don't mind. So let's jump straight to them. So the first one's here. Hope you can see it. Is it possible to build professional industrial IoT device with ESP328266? Not sure I get that fully, but I hope you do.
It's a different board. Like the ESP32 is mature, and the last one is like less resource. Yeah, for sure. Actually, a lot of companies they doing that. Like some solution actually using Arduino, and it's actually like it is fine to use such a solution, because like ESP32 and Arduino, they are not just for the prototyping. They can actually be used in production environment too. But it's actually depend from requirements, like what kind of requirements and budget. Sometimes ESP32 may be like can be more expensive than, for example, STM32. Because it's a bigger company, they provide far more, a lot of different boards, a lot of different chips, and you can choose the chip which actually better for you. And ESP32, there are no a lot of options there. But yeah, for sure you can use that for production and a lot of company use because it has already Bluetooth, Wi-Fi, a lot of resources, which is good enough for solution. So yeah, why not?
Thank you. Got another one here. It's about tooling. Let me just show it so that I could also read it. Is there any tooling to simulate IoT devices, including modeling of the electronics? The goal is to install and test the firmware on simulator instead of physical devices.
No, as I know, like uh, I worked with company like embedded company which is create embedded solutions, and they test all influencing by using real hardware and real environment. There can be some mathematical like prototype to understand how the system can behave, but everything was checked in the end. Everything was checked by real environment in the boxes, big boxes. So and they're actually, you know, that's the a lot of IoT systems around this box, and they actually check other IoT systems. So you build your IoT device by using other IoT device, and they checking that you do everything like in the right way.
I see. Thank you. And just one more questions because we are unfortunately we're running out of time. So the last one is about Zeek. Does Zeek have a future, in your opinion, in concept of IoT and in general as a system language?
Uh, yeah, it's the like in not new, but also a good programming language. But as I understand, maybe it's because the Rust actually like exists, or I don't know the reason, but it's not so popular. For example, compared to the Rust, and not many company they adopting Zeek. But
I see.
I saw that like little bit research that topic, and I saw that it's also a good language. But I would say it's mm, why using Zeek if you have Rust, for example.
Yeah, it's not the time for Zig yet, right? Because we
Yes.
have other options available that are getting more and more popular.
Yeah,
Thank
I
you.
think they need just show that what the advantages they bring to the industry compared to other languages. Rust show the advantages compared to C and C++, and like the question is, can Zig show the advantages compared to Rust, for example? I don't think so right now.
Yeah, yeah, it does actually take time for the community to develop, for more frameworks to be developed. All right, well, thank you so much. I
Yeah, thank you.
understand that that's the topic that can be spoken of for quite a lot of time. The potential of various programming languages for the IoT industry, and I wish we had that time. But thank you so much, Mikhailo, for an amazing. Insights, as well as a great example of how it can work and how it easily can be actually done for such purposes. Thank you so much for sharing it. And all right, but yeah, unfortunately, we have to draw everything to a conclusion. It was a great event, so many insights. And before we go there, before we round up our event, just wanted to let you know that Mykhailo has written a really cool and quite a comprehensive blog post on what are the perspectives of Rust in IoT development, the advantages, the disadvantages, as well as other peculiarities. Those will be included. And if you want to, we will also send it to your email box with the thesis from the presentations of our amazing guides and amazing experts today. And guys, I just wanted to thank you all for being a part of this live stream session. I understand we can't address all of the queries, but we are definitely eager to continue the conversation. So that's why we have put the channels of communication with us into the chat, please have a look at our email address, at our website, at our YouTube channel and LinkedIn channels. Subscribe to us so that you could get more amazing insights and engage in such great live streams, and just watch the recordings of our previous live streams. Do not hesitate to message us on LinkedIn or send us an email, or complete the contact form in case you are looking to create an IoT product and are thinking to use Rust and are considering the quality aspects of developing an IoT ecosystem or an IoT product or some kind of IoT device that requires software. And additionally, we'd love for you to join the community on LinkedIn. Please do not hesitate to go and give a shout out to Artur, Shevchenko, and Mykhailo Maidan on their LinkedIn pages, as well as Yalantis' LinkedIn page. Don't forget to subscribe to us, guys. You'll definitely find a wealth of IoT resources, updates, and insights to keep you informed and inspired. And once again, thank you for joining us today, for spending your time diving deep into the IoT testing and exciting potential of Rust in IoT development. We're here to help you innovate and scale your solutions with confidence. And please stay connected, and look forward to welcoming you to our next events. Hope you had a great time. Bye-bye.